I'm just going to erase this real quick. And I know that the square root of x minus 2 has, I'm just going to put 1, 2, 3, 4. I think I went all the way, I extended it. And I went to 6 because if I put a 6 into that 6 minus 2 in the denominator, it gave me 4, and the square root of 4 is 2, which gave me 1/2. So if I do like 1 here, this point is going to be 6 1/2. There's a vertical asymptote right here. And there's also a value, if I put a 3 in for x, I get the square root of 1 in the denominator, which gives me 1. And so we know this approaches infinity here and then comes down like that. And that's what that piece of the graph would look like. I'm not going to worry because it's only asking us to integrate from 2 to 5. So I'm not going to worry about anything on the other side. And actually, I wouldn't even have values on the other side now that I'm looking at it, because that would give me a negative underneath the root. Okay, so this is it for 0, 5. Why would the integral from 2 to 5, 1 over the square root of x minus 2 dx, be considered improper? And I think you should think about that, but I think you probably all already recognize that because there is a vertical asymptote at x equals 2, that is why it would be improper. And so I would say integral from 2 to 5, 1 over square root of x minus 2 dx is considered improper. Because there is a vertical asymptote. Oops. Comma, infinite discontinuity, because a vertical asymptote gives you an infinite discontinuity at x equals 2. Okay? So, solve the integral from t to 5. 1 over x square root of x minus 2 dx. Okay, so this time they want us to go from t to 5. So if I integrate from t to 5, and I'm going to make this x minus 2 to the negative 1/2 dx. I really don't know what t is. T could be, it could be 3.2 or something. I don't know. So I'm going to go ahead and say that I would be adding 2 over 2, so that would give me a positive 1/2, and then I would be dividing by positive 1/2, which is multiplication by positive 2, from t to 5. And this would be, if I put a 5 in, I'd get 2 times the square root of 3, because 5 minus 2 is 3, to the 1/2 is square root, minus 2 times the square root of t minus 2. So that's when we don't know what t is. If we knew it was 2, for this one, t would have to be greater than 2, right? We would want t to be greater than 2 because of what's underneath the root. But also, why could it not equal 2? Well, because then we wouldn't have been able to do the integration like this. Now they want us to find the limit as t approaches 2 from the right. So the limit as t approaches 2 from the right. And see, that makes sense, because remember when I was telling you that you have all this, and you're coming in from the right because that's where your area is. Okay, so you have to decide on those vertical asymptotes what, you're on the right of that 2. So you're coming in from the right, even though you're going from 2 to 5. And this would be integral from t to 5, x minus 2 to the negative 1/2 dx. And we already solved that one. Limit as t approaches 2 from the right. We said that this was 2 times the square root of 3 minus 2 times the square root of t minus 2. So that's going to give us 2 times the square root of 3 minus, now think about, if I put 2 in, like what if I put 2.0001 in? This thing is going to 0. So what's going to end up happening here is that this goes to 0 as t goes to 2 from the right. And so that's going to give us minus 0 there. 2 times the square root of 3 is our answer, which means that this is convergent. Okay. So now, type 2, case 1 and 2.